This is a probability distribution sum. So just a little reminder, this is a probability distribution table. Now remember, in a probability distribution table we should have a table where the random variables are given, random variable, and the probability for each of the random variable is given. So 1, 2, 3, 4, 5. This is the random variable, and the probability of each of the random variable will be given. The first question is usually find the constant. Find the constant. And we find the constant by adding up all the probability together, because total probability is 1. Now in this particular sum we don't have a table. Usually we have a table, but in this sum we don't have a table. So it's a good idea to draw the table ourselves, because they did not ask for a table. So if we draw the table, it would be like this. So we'll have the random variable is 1, 2, 3, 4 and 5, and every probability is given here. So for 1 we have to use this probability rule, kx. So x is 1, it would be k. For 2 it would also be kx, meaning 2k. For 3 it would be kx, meaning 3k. Now for the next two random variables we have to use a different rule for finding the probability. It has to be x plus 1 into k. So for 4 it will be 4 plus 1, meaning 5k. For 5 it would be 5 plus 1, meaning 6k. Okay, so now that we have the probabilities written out like that, we can just add them up and find the constant. So find the value of k. So now we can write it out. Therefore k plus twice k plus thrice k plus 5k plus 6k equals to 1. We don't need the calculator for this, we can easily do this. Here we have k plus 2k is 3k, 3k plus 3k is 6k, 6k plus 5k is 11k, and 11k plus 6k is 17k. So this would be 17k equals to 1. Therefore k equals to 1 by 17. So we know the value of k. So the next question is expected value, ex. Expected value means mean. So let me write down the formula here. So find the expected value, and the expected value has a formula of summation of random variable into probability. That's it. So what we can do here is, we know the table. So for expected value, what we can do, we have to write it out. So expected value equals to 1 into k, which means 1 by 17, plus 2 into 2k, which means 2 by 17. Remember, k is 1 by 17, so 2k means 2 into 1 by 17, 2 by 17, plus 3 into 3k, which means 3 by 17, plus 4 into 5k means 5 by 17, and 5 into 6k is 6 by 17. That's the value here. So let's bring the calculator out. Now one thing about the calculator is that only the calculator doesn't understand division, meaning it has some trouble, so you need to use brackets. But otherwise, plus, minus, multiplication, division, apart from that, the other ones can be done very straightforward. So good habit is always to do, remember that some of the calculation do it in your head and the rest do it in the calculator. So 1 into 1 by 17 is 1 by 17, plus 2 into 2 by 17 is 4 by 17. So instead of writing 2 into 2 by 17, just write 4 by 17. 4 by 17. 1, 7. Okay. Plus 3 into 3 by 17 is 9 by 17. Plus 4 into 5 by 17 is 20 by 17. Plus 5 into, let me bring it here, 6 by 17 is 5 6 is 30 by 17. It's much easier to do this calculation, so this would be shift ABC, 64 by 17. So the answer would be 64 by 17. Okay, the next one. The next one is variance. Now show that to three significant figures, variance of x is 1.47. Now they told you to show that the variance is 1.47, but remember you have to find the variance to 5 decimal places. This is just how you write the answer, but the calculation should be full. So formula for variance is, let me write it down here. So the formula for variance is variance of x equals to summation of random variable square into probability minus mean squared. Now this thing has a special name. This thing is called ex squared. If you want to know, this is called ex squared, and this is called expected value. The mu is expected value, and then you do whole square of that, right? So variance can also be written ex squared minus expected value whole squared, but for the time being let's skip to this. It's the same thing, but it doesn't really matter how you represent it. So let's write it down. Variance of x as equals to, so data squared, 1 squared into probability is 1 by 17 plus 2 squared probability is 2 by 17. So what we can do here, plus 3 squared, it would be 3 by 17 plus 4 squared, that would be 5 by 17 plus 5 squared, that would be 6 by 17, and remember minus mu squared, so that would be minus 64 by 17 whole squared. Okay, so let's do the calculation. So we need, so 1 squared into 1 by 17 is 1 by 17 plus 2 squared into 2 by 17 is 2 squared is 4, 4 to the 8 by 17, that would be 8 by 17. So like that, do some of the calculation in your head and the rest of it in the calculator. 3 squared into 3 is 27, 27 by 17 plus 4 squared is 16, 16 into 5, let's do this like this, 16 into 5 by 17 plus 5 squared is 25, 25 into 6, so 25 into 6 by 17. So that means this minus, we have 64 by 17, so we have, let's put it in a bracket, 64 by 17 whole squared. That makes it 1.474048, 1.474048, and they told us to write down the answer as 1.47, so we can write it now. We can write down the answer as three significant figure 1.47. So that's done. Let's move on to the next one. Question number D. So in this question they're asking us to do about question about coding. So variance of 4 minus thrice x. So that's what we have to do. So let's do this. So variance of 4 minus thrice x. Now first of all, coding formula for variance is that if it is variance of ax plus b, in coding it is the coefficient of the random variable a, so a squared into the variance. That's it, that's the coding, and the plus b just disappears. So if you want to do this, that means we can write this as variance of minus 3x plus 4. Same thing, just writing it in this order. So the coefficient of the random variable is minus 3, so minus 3 whole squared into the variance. So minus 3 whole square is 9 into the variance. Now remember, you cannot use 1.47 because that's a rounded answer. It's just for the answer. If you use the full form, it would be 1.474048. So the answer would be, let's bring out the calculator, 9 times 1.474048. That would be 13.2664. So 13.2664. So that would be the answer. Now the answer has to be in one decimal place. So therefore, variance of 4 minus thrice x would be 13.3. So let me check. Is it? Yes, it is one decimal places. So this is the question. Now this is question number 6. This is based on normal distribution. So it's a normal distribution sum. Now a normal distribution is given like this. So normal distribution. So this is a regular normal distribution where the mean is given and the variance is given. Remember, this is mean and this is variance. And when we have to find the probability, we have to convert this normal distribution because it has a unit, maybe kg or centimeter or centimeter square, but to make this unit free. So this is called Z table, or the standard normal distribution, where the mean is 0 and the variance is 1. We write it as 1 squared. So to do this, we need a formula called the z-score formula. Let me write down the z-score formula here. The z-score formula is z equals to x minus mean divided by sigma. Remember, this is sigma, the standard deviation, and this is sigma squared, the variance. There is a difference. So that's how it works. So let's start this sum. So the first is to write down the normal distribution definition. A scientist found that the time taken m minutes. So I wrote x. So remember, we have to follow the question. So the random variable should not be x here. The random variable should be m here. So m minutes. So the random variable is m. Normally distributed to carry out an experiment can be modeled by a normal random variable with mean 155 minutes. So the mean is 155 minutes. And the standard deviation, remember the sigma standard deviation is 3.5, but we have to put here sigma squared. This would be 3.5 whole squared. Sometimes they give standard deviation in the question, sometimes they give variance directly. In that case we can write that, but here it has to be sigma squared. So the question is, probability of m is greater than 160. That's what we have to find. So the first step for normal distribution is to convert into z-score. So z is greater than x minus mu divided by sigma. X is 160, mean is 155, divided by sigma is 3.5. So let's calculate. So probability of z is greater than, let's bring out the calculator. So this particular sum would be 160 minus 155, that is 5, divided by 3.5, that is 1.4286. 1.4286. So that's what we have to do. Now remember, this is z is greater than, but the table at the back of the book is always in less than format. So let me write this out. Table. So for looking at the table, it has to be z is less than a. It can also be z is less than or equal to a. It doesn't really matter because it is continuous. Less than or less than equals to is the same thing. So what we need to know is, if it is probability of z is greater than a, then we have to make it less than by this rule, 1 minus probability of z is less than a. So this is what it needs to be. So let's write this out. 1 minus probability of z is less than 1.4286. Now let's look up the table and find this out. Now let's take a look at the formula booklet that would be given in the exam. Now this is a formula booklet. This formula booklet will be given in all the exam, be it C1 to C4, M1, S1, S2, or FP1, FP2, FP3. This formula booklet will be given. Now if you go through the pages, this is the content, and we have S1. these are the formulas, some probability formula, some discrete distribution, some correlation regression formula, normal distribution function. This some information is given. So let's see what's in S1. So here this is some probability formula, this is some expected value formula, variance formula. They have given different formats of the formula, but we will stick to the ones that we use. So this is some more formula, sum of x, sum of xy, sum of y formula, regression formula. You can see that there are different formats of that formula, and this is something you can use by your choice, but we are going to stick to the ones that we use. So this is the normal distribution page. Now if you take a look at our what we have to look for, it is z is less than 1.4286. So we are looking for, look here, this is z is less than everything, this is z and this is the probability. So if you're looking for 1.42, there are only two decimal places here. So if we look here, 1.4, that would be, let me enlarge it. So we have this 1.42. Remember what we have is 1.428, so this should be 1.43. it will be increased by one decimal places. So 1.43 is this one, 0.9236. 1.43 is 0.9236. So let me write it down, 1 minus 0.9236. let me double check. 1.43 is 0.9236. That's all right. So let's subtract this, bring out our calculator. This is 1 minus 0.9236. So the probability should be 0.0764. So 0.0764. So that's the probability of A, 0.0764. Let's do the next one. So the next one is we have to find the probability in between. So let's do this. So the first question is probability is 150 and probability is 157. So z-score would be, therefore probability of it should be 150 minus, let me check the mean again. The mean is 55 and the standard deviation is 3.5. So 155. Okay. So minus 155 divided by 3.5 z 157 minus 155 divided by 3.5. So this would be 150 minus 155. It is minus 5. So minus 5 divided by 3.5. So 3.5. So that is going to be minus 1.4286. Minus 1.4286. Remember, in continuous random variable, if you give equal to sign or no equal to sign, it makes no difference. So I'm just going to get rid of the equal to sign. I'm going to write it like this. So 157 minus 155 is 2. 2 by 3.5 is going to be 2 divided by 3.5. So it is going to be 0.5714. So 0.5714. Now how do we calculate this? So the rule is this: when you want to look up the table and you have something like this, so for the table you need z is less than a, or it can be equal to sign. So when you have something like this, z is between a and b, what you need to subtract this and this. So probability of z is less than b minus probability of z is less than a. So this is what you need. You need to subtract this minus this, this minus this. This is what you need. So what we can write here is probability of z is less than 0.5714 minus probability of z is less than, just leave it as it is, minus 1.4286. So we can look this up in the table. 0.5714 means 0.57. Let's look this up. 0.57 is going to be, this one is 0.57. This one is going to be 0.7157. 0.7157. Now this one is negative. Now in the table we can only have z is less than a positive number. So what can we do here is, whenever you see something that is negative, so probability of z is less than negative a, to make it positive you just reverse this inequality and it will become greater than, and this would become positive. So that's the rule. Whenever you have a negative symbol, what you have to do is reverse this and this change the inequality, it will become positive. So this would be probability of z is greater than, it would be 1.4286. So 0.7157 minus, now this probability we have to again convert it, since it is greater than, we have to convert it into 1 minus. So this should be 1 minus probability of z is less than 1.4286. So this should be 0.7157 minus 1 minus, so probability of z is less than 1.43. 1.43 is going to be this one, 1.43, 0.9236, 0.9236, 0.9236. So let's calculate this. So this one would be, with the calculator, let's check this, 0.7157, so 0.7157, write this down, 0.7157 minus bracket 1 minus 0.92 0.9236, 0.9236. So the probability is going to be 0.6393, 0.6393. Now the next one is a different type. It's type 2. So here the probability is given and we have to find the random variable. So here the probability is given and we have to find the random variable. But before we do this, let's first do the z-score, because either way you have to do the z-score first of all. So z is less than or equals to m minus 155 is the value of mean, divided by the standard deviation is 3.5 equals to 0.30, and 0.3 is the same thing, doesn't really matter. So the probability doesn't change when you do z-score. So in this type of sum, let me name this type 2. What I mean by type 2 is that here you don't have to find the probability will be given. What you have to do is find the random variable. So here there is a special table that you can use, and that table is, this is the normal distribution table, and if you go to the next page you will find another table. This is the percentage normal distribution table. Now this table is a bit different. Let me enlarge this. This table is a bit different in that sense that it is a greater than table. Usually the normal distribution table is z is less than, this table is z is greater than, and here this is specially made for that type 2 sum. Here the probabilities are given and here the random variables are given. So if you take a look here, so if we can make this greater than, now this is less than, we can very easily make this greater than just by writing out like this: probability 1 minus probability z is greater than m minus 155 divided by 3.5. Remember, this is continuous, so equal to sign doesn't really matter. What I'm interested in, this rule that I mentioned before, is when we talk about probability, if it is z is greater than a, we can write 1 minus probability of z is less than a, and if it is z is less than a, we can write 1 minus probability of z is greater than a. Either way this is correct. Convert it into another format. So for this particular sum, what we can do, this was less than, so I wrote 1 minus this, and this is 0.3. Now if we do this, if I send this to this side and send this to that side, it is 1 minus 0.3. This probability of z is greater than m minus 155 divided by 3.5. So this becomes 1 minus 0.3 is 0.7. So what we get here is this. Probability of z is greater than m minus 155 divided by 3.5 equals to 0.7. Let's take a look at that paper. Do we have 0.7? No, we don't. Here the probability is up to 0.5, so we cannot use this table. So you should have an idea whether we can use this or not. We can only use this table if it is greater than by default. If it is not greater than, we cannot use this table. So let's just remove this. Let's clear this out. Let's just clear this and let's get back to the beginning. Let me clear this. So we can only use this if it is at the beginning we have this information z is greater than. But if it is not z is greater than, then it is better to use another technique. So this is the technique that I prefer. When you have z is less than, the best thing to do is draw a picture of the standard normal distribution. Remember, this is 0. So you know less than, z is less than and the area is 0.3. Less than means the left hand side of the diagram, and you know the total area is 1. Half of the area is 0.3. So if less than, if it is on the less than side and on the left side and it is 0.3, so it should be like this. This region should be 0.3. This region should be 0.3. And this is definitely negative. Less than 0 is negative because it's the standard normal distribution. So instead of this thing, let me write, therefore probability of z is less than minus a equals to 0.3. So you know when it is less than and it is negative, you can just reverse the symbol. Greater than a equals to point a. Then if you have greater than, you can write 1 minus probability of z is less than a equals to 0.3. Remember, in continuous equal to sign, whether you give it or not makes no difference. So we can write it as 1 minus 0.3 equals to probability of z is less than a. And let me continue here. So we can write probability of z is less than a equals to 0.7. Now let's look up the table. This table is not going to work for us, so we're going to move on to the previous table, the main table. So here let's take a look at the probability. We need a probability of 0.7. So let's look for a probability of 0.7. 0.5. Let's look in the probability column. There is nothing here. Let's go up. 0.7. Now we have two choices. We can either take 0.6985 or we can take 0.7019. Either one will do, but it's preferable to take the closest one. If you take 0.7019, it is 19 more than 0.7. Actually 0.0019 more. If you take this one, it is only 15 less than 0.7. So this is closest, 15. So the value of z for this probability is 0.52. So I can write, therefore probability of z is less than 0.52 is equals to 0.6985. Now that we know the value of a, we can just write this equals to minus a. After all, it was this. Instead of this, I wrote minus a. So I can write it here. Let me write it here. Therefore m minus 155 divided by 3.5 equals to minus a. A is 0.52. A is 0.52. Remember, the substitution was for minus a. So let's do the calculation. I can write m minus 155 equals to minus 0.52 into 3.5. Therefore m equals to 155 minus 0.52 into 3.5. Now let's do the calculation here. So the calculation would be 155 minus 0.52 multiplied by 3.5. So that would be 153.18. 153.18. That is the value of m. Now in the question they said write the answer to 1 decimal places. It should be write down the answer of m to 1 decimal places. So answer should be m equals to 153.2. That should be the answer.